Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. Imagine this scenario. A bank deploys an AI agent to help process financial workflows. The agent misinterprets a policy, takes an action it wasn't supposed to take, and nobody catches it until money has already moved. That's the difference between generative AI and agentic AI. A chatbot can give you a bad answer. An AI agent can potentially take a bad action. And that changes everything: security, governance, operations, architecture, and the IT skills employers are going to need. So forget the hype for a few minutes. Let's look at what Agentic AI actually is, where it breaks in the real world, and how you can build a career around making these systems work safely. Agentic AI doesn't just respond to prompts. It plans, decides, and executes multi-step tasks with minimal human input. Think: a system that sets a goal, breaks it into subtasks, calls APIs or databases on its own, performs an action, and observes the result. That's a structural difference from old chatbots that just spit out a paragraph. We call this the agentic loop, and it's why the stakes are so much higher. Agentic AI is surrounded by enormous expectations. Vendors are promising autonomous digital workers that can plan tasks, use tools, interact with applications, and complete entire workflows. But enterprise adoption is much harder than the demos make it look. A prototype might successfully call an API in 5 minutes. Production means authentication, permissions, unreliable dependencies, sensitive data, monitoring, cost controls, error handling, audit logs, security, and governance. That's the gap you need to understand. The impressive part isn't making an agent work once. It's making it work safely and predictably thousands of times. Let's break the gap wide open. On the red side, the promise. On the green side, what's actually shipping? That agentic solution your vendor is pitching? Probably a chat interface hooked to a few APIs. But the dangerous part is that agents act on outputs. A chatbot hallucinates a wrong answer. You roll your eyes. An agent hallucinates a compliance rule and wires $2 million to a fraudster. That's not a demo fail. That's a career-ending incident. Enterprises are learning this the hard way. Here's where promising agent projects start running into reality. The model may work perfectly in a demo. Then you connect it to enterprise data and discover that information is incomplete, inconsistent, outdated, or scattered across multiple systems. Next come the integrations. APIs fail. Authentication expires. Schemas change. Permissions are too broad. Tools return unexpected results. Then comes governance. What is the agent allowed to do? Which actions require approval? What happens when it's wrong? Who is accountable? Can you reconstruct exactly what happened afterward? This is why building an agent is often the easy part. Building an agent you can trust in production is the real engineering challenge. The companies that get this right follow a structured path, what analysts call the yellow brick road. First, get your data house in order: unified, clean, context-rich. Then integrate those data sources with APIs and knowledge graphs so agents can actually interact with live systems. Wrap it all in governance before you ever deploy an agent. Skip straight to building agents, and you're guaranteed to fail. This unsexy foundation is what turns a flashy demo into something that works in production. The important career shift isn't that every traditional IT job is disappearing. It's that AI is changing what employers expect those jobs to do. Developers are being asked to integrate AI into applications. Cloud engineers are deploying AI workloads. Security teams are defending AI systems. Operations teams are monitoring them. Data engineers are building the pipelines that feed them. And architects are figuring out how agents safely interact with enterprise systems. That means you don't necessarily need to abandon your current IT career. You need to understand where AI connects to it. Don't expect every opportunity to have Agentic AI in the job title. The bigger opportunity is AI being added to jobs that already exist. Software engineers will build agent-enabled applications. Cloud engineers will deploy the infrastructure. Security engineers will secure agent identities, APIs, and data. DevOps and platform engineers will automate deployment and monitoring. Data engineers will connect agents to trusted information. Enterprise architects will determine where agents should and should not be allowed to act. That's why existing IT professionals have an advantage. You're not learning an entirely new industry. You're adding AI to one you already understand. So which IT and business tasks are most exposed? Look for work that is repetitive, rules-driven, digital, and easy to verify. Customer support is a good example. In some organizations, AI systems can already help classify a request, retrieve account information, draft a response, recommend an action, and document the interaction. But adoption varies significantly by industry, company size, risk tolerance, regulation, and the complexity of the workflow. That distinction matters. Agentic AI isn't eliminating entire professions overnight. It's increasingly automating pieces of jobs that follow predictable, information processing patterns. The career lesson isn't to panic. It's to move beyond simply executing the workflow. Learn how to design it, integrate it, monitor it, secure it, troubleshoot it, and decide when a human should take over. At the same time, Agentic AI is creating new responsibilities, and in some cases, entirely new roles. Organizations need people who can design agent workflows, connect agents to enterprise systems, monitor their behavior, evaluate their outputs, secure their identities, control their permissions, and establish governance around what they're allowed to do. Some of that work will become dedicated AI roles, but much of it will be absorbed into jobs that already exist: software engineering, cloud engineering, DevOps, cybersecurity, data engineering, platform engineering, and enterprise architecture. One emerging concept is especially relevant to IT professionals: AgentOps. Think of it as applying production operations principles to AI agents, and that's where we're going next. When cloud matured, DevOps created a whole new role. Agentic AI is doing the same thing right now. Meet AgentOps, the people who deploy, monitor, and maintain AI agents in production. They track agent behavior in real time, catch anomalies, handle versioning and rollbacks, and build dashboards that show reliability, cost, and accuracy. For IT ops pros who already understand monitoring and incident response, this is the most natural pivot in the Agentic era. It's not about building the AI, it's about running it safely at scale. Building a basic agent is becoming easier. Building a reliable workflow around that agent is where the engineering begins. Agent orchestration means controlling what happens across multiple steps: which tool gets called, what state gets preserved, what happens when a tool fails, when the workflow retries, when it stops, and when a human needs to take over. That's why frameworks such as LangGraph matter. But don't memorize a framework and mistake that for the skill. Learn state management, conditional routing, retries, timeouts, structured tool calls, checkpoints, and human approval. Frameworks will change. Those engineering problems won't. Specialization isn't disappearing. Deep expertise in security, networking, cloud, data, or software engineering is still extremely valuable. The vulnerability is being specialized in one repeatable task without understanding the systems around it. If your entire role is generating the same report, routing the same type of ticket, or following the same predictable workflow, AI may automate more of that work. But deep domain expertise combined with integration skills is different. The security engineer who also understands APIs, identity, automation, and AI becomes more valuable because now they're helping determine what an agent should be allowed to do. Don't abandon specialization. Connect it to the rest of the enterprise. Think about two people who both know SQL. The first person runs a fixed set of reports every week. The second understands database architecture, data quality, APIs, permissions, business requirements, automation, and how downstream systems consume that information. AI may automate much of the first person's workflow. The second person becomes increasingly important because somebody still has to design, secure, validate, and troubleshoot the system performing that automation. That's the career pattern to remember. Don't just become good at performing a task. Understand the system that makes the task possible. That's why the T-shaped career model becomes so useful. The vertical part of the T is your deep expertise. Maybe that's cloud, security, networking, data engineering, software development. Keep building that depth. The horizontal part is your ability to work across APIs, data, automation, AI, security, monitoring, and business processes. Agentic systems cross those boundaries constantly. The professionals who understand one domain deeply and can connect it to everything around it are going to be extremely difficult to replace. Build the stem, then build the bar. Many agent projects don't fail because the model can't generate an answer. They fail when that model has to interact reliably with messy enterprise systems. The agent needs trusted data. It needs APIs. It needs authentication. It needs predictable schemas. And it needs a way to handle missing, outdated, or conflicting information. For IT professionals, this is an enormous opportunity. Learn SQL, learn REST APIs, understand JSON, learn one cloud data platform, understand document ingestion and retrieval. Then learn how an agent securely connects to those systems. The glamorous part is the AI. The valuable part is making the AI work with reality. Prompt engineering still matters, but the job has expanded. With agents, you're not simply asking a model to write a better paragraph. You're designing the information and instructions the system needs to make reliable decisions. That includes system instructions, context, structured outputs, tool definitions, schemas, retrieved knowledge, conversation state, and guardrails. If an agent needs to create a support ticket, for example, don't let it invent whatever parameters it wants. Define exactly what the tool accepts. Validate the output. Restrict what actions are available. And decide what happens when the model is uncertain. The future skill isn't finding magic words. It's engineering reliable context around the model. A production agent needs observability for the same reason a production application does. You need to know what happened when something goes wrong. Which prompt did the agent receive? Which tools did it call? What parameters did it send? What did those tools return? How many steps did the workflow take? How long did it run? How much did it cost? And where did the failure begin? Agent observability platforms and traditional monitoring tools can help answer those questions. The specific products will change. The important skill is understanding what needs to be measured. If you can build an agent, that's useful. If you can explain why it failed at 2 a.m, that's production engineering. Security is the hard requirement for enterprise agentic roles, and the fastest way to get rejected if you can't speak to it. Agents that call APIs and make decisions are attack surfaces. Prompt injection, tool misuse, data exfiltration, unapproved actions. The NIST AI Risk Management Framework is a key voluntary framework to know. Concrete move. Implement human-in-the-loop approval for any high-risk agent action. A refund over $50? A command that touches production infrastructure? Pause and require a human sign-off. This isn't optional. It's what separates a toy from a system an enterprise will actually deploy. LangGraph and CrewAI are two approaches you'll encounter when learning agent orchestration. LangGraph gives you explicit control over workflow state, routing, tool execution, and human intervention. CrewAI focuses heavily on organizing agents around roles, tasks, and collaborative workflows. Both can teach useful patterns. But here's the career lesson. Don't become the LangGraph person or the CrewAI person. Learn why workflows need state. Learn when multiple agents are actually necessary. Learn retries, timeouts, structured outputs, observability, and human approval. Then you can move between frameworks as the ecosystem changes. Learn the architecture first. Learn the product second. Your first agent doesn't need to be complicated. Start with a local model or another development environment you're comfortable with. Give the model access to one simple tool, maybe a calculator, a small lookup function, or a safe test API. Then ask a question that requires the model to decide whether that tool is needed. Watch the workflow. Did the agent select the correct tool? Did it generate valid arguments? What happened when the tool returned an error? Now intentionally break something. Give it an invalid input. Make the tool fail. Add validation and error handling. That's when you stop following a tutorial and start learning agent engineering. When Agentic AI goes wrong, it usually fails in one of 4 predictable ways. Infinite loops. The agent retries a failing tool call forever because nobody set a max step count. Stale tool calls. The agent passes a hallucinated parameter to a real API, corrupting data. Hallucinated actions. The agent invents a tool that doesn't exist and tries to execute it anyway. Remember, agents act on outputs, so this isn't a bad chat response, it's a real side effect. Cost explosions. Long agent chains burn tokens fast, and without cost caps, a single query can run up a surprisingly large bill before you realize it. Every one of these has a straightforward fix: timeouts, schema validation, action guardrails, and cost limits. Add them before you let an agent touch anything real. You don't need access to production systems to start building agentic AI skills. Use synthetic or sanitized data and build projects in your own lab. Project 1. Create an IT ticket triage agent that categorizes simulated tickets, estimates urgency, and recommends a routing team. Project 2. Build a runbook assistant that searches approved documentation and drafts troubleshooting steps. Project 3. Build an incident triage assistant that summarizes synthetic logs, identifies suspicious events, and recommends what an analyst should investigate next. And Project 4. Build an approval-based remediation agent. Let the agent recommend an action, but require human approval before the action can execute. That last project teaches one of the most important lessons in enterprise AI. Autonomy doesn't have to mean unlimited authority. When you study agent-oriented engineering roles, you'll notice that the valuable skills extend far beyond prompting. Python appears frequently because agents need application logic. APIs matter because agents need tools. Cloud skills matter because enterprise AI runs on infrastructure. Data engineering matters because agents need trusted information. Observability matters because somebody has to troubleshoot failures. Security and governance matter because agents may be allowed to take real actions. And communication matters because somebody has to explain the risks, controls, and business value to people who don't build AI systems. Use those categories as a skills gap assessment. Don't ask, which AI course should I take next? Ask, which capability am I currently missing? Think of Agentic AI as a stack. At the foundation, programming fundamentals, especially Python, plus APIs and structured data. Next comes agent orchestration, tools, workflows, state, routing, retries, and human intervention. Then infrastructure, cloud, containers, deployment, identity, secrets, and networking. Above that comes observability, tracing, logs, evaluation, performance, reliability, and cost. Then security and governance, least privilege, approval boundaries, auditability, data protection, and risk management. And at the top sits domain expertise and communication. Because ultimately, somebody has to understand what the business is trying to accomplish and whether the agent should be doing it at all. You don't need to master everything at once. Build the stack one layer at a time. A cooling hype cycle isn't necessarily bad news. It's often when the interesting engineering starts. During the hype phase, everyone focuses on demos. Can the agent book the meeting? Can it answer the question? Can it complete the task? Production asks harder questions. Can we trust it? Can we secure it? Can we monitor it? Can we control its cost? Can we explain what it did? Can we stop it when something goes wrong? That's where experienced IT professionals become valuable. The future of agentic AI won't be determined by the flashiest demonstration. It'll be determined by whether organizations can operate these systems reliably. Here's a quick test you can use whenever someone calls a product agentic. Ask 4 questions. Can the system plan multiple steps toward a goal? Can it decide when to use external tools or data? Can it take an action rather than simply generate content? And can it observe the result and adjust what it does next? The more of that loop the system controls, the more agentic the behavior becomes. Don't get distracted by product labels. Look at what the system actually does. Here is a 4-week plan. 0 cost, all free resources. Week 1. Refresh Python basics, then follow the LangGraph quick start to build a weather agent with Ultima and a free API. Get a single tool calling agent working locally. Week 2. Study LangGraph fundamentals, state management, multi-step flows, conditional routing. Add a second tool and watch the agent decide which one to call. Week 3. Add Langsmith for tracing and monitoring. Set up cost tracking, error handling for hallucinated tool inputs, and understand what production observability actually requires. Week 4. Build a portfolio project, a document QA agent that reads a policy PDF and drafts an answer but requires a human approval step before sending. Push it to GitHub. That one repo shows more competence than 10 vendor certification badges. When you're learning agents, don't spend all your time watching polished demos. Study how reliable systems are designed. Look at official framework documentation and reference architectures. Study examples that include tool calling, state management, retrees, checkpoints, human approval, and observability. Then look at enterprise AI research to understand why organizations struggle to move prototypes into production. And whenever you examine an example, ask the same question. What happens when this fails? That's the difference between copying a tutorial and thinking like an architect. If you already work in help desk, systems administration, networking, cloud, DevOps, or cybersecurity, don't assume AI has made your experience obsolete. Agentic AI doesn't live in a notebook. It runs on infrastructure. It authenticates to services. It calls APIs. It accesses databases. It uses identities and secrets. It generates logs. It fails. And somebody has to troubleshoot it when it does. Those are IT problems. Your advantage is that you already understand the environment AI is being connected to. Now add the orchestration layer. Models, tools, structured outputs, agent workflows, retrieval, evaluation, and guardrails. You're not starting your career over. You're extending the skills you already have into a new layer of enterprise technology. Now here's the trap that catches most people. They see a flashy demo from a vendor, an AI agent that does some magical thing in 60 seconds, and they think, I just need to learn that tool. Wrong. Tools evolve constantly, but the principles, Python, orchestration, monitoring, security, those endure. So spend about 80% of your time on those core skills and no more than 20% on any specific tool. Future-proof your career, not your tool stack. Here's your challenge. Don't spend the next month watching agentic AI demos. Build one. Start small. Create an agent that can use one tool. Then add structured output. Add error handling. Add logging. Give it limited permissions. Finally, require human approval before it performs a sensitive action. Document the architecture, what went wrong, and how you fixed it. You don't need to become an AI researcher. You need to understand how to turn an AI prototype into a system you could trust. Agentic AI isn't replacing the fundamentals of IT. It's being built on top of them. Infrastructure still matters. Data still matters. Identity still matters. Security still matters. Monitoring still matters. The difference is that now, AI can act across all of them. Learn how to connect those systems safely, and you're not competing against AI. You're becoming the person organizations need to make AI work. Go build something.